Hey, Audrey, you know how we're always talking about the next big thing in tech? I've got something huge for you today. Remember all that buzz about quantum computing and how it's super powerful, but also incredibly hard to actually use effectively?
Oh, absolutely. It always sounds so futuristic, but then you hear about all the hurdles, the whole quantum bottleneck thing, right? Like amazing hardware, but getting it to do what you want is like a whole other story. What's new on that front?
Exactly. So, Quantum Elements, this really cool Los Angeles startup, just officially launched their new platform called Constellation on October 22nd. And it's AI native, which is it's a game changer. They literally emerged from stealth mode with funding from some serious players like Quantum Delta Netherlands and USC Viterbi. It's designed to revolutionize how we build, test, and actually use quantum computers. No more bottleneck, hopefully.
Wow, Constellation. That sounds super cool. So what does AI native even mean in this context? How does it actually tackle that bottleneck? Because that's always been the core challenge, hasn't it? Getting it from theory to practical application.
Okay, so here's where it gets really, really cool. One of the biggest pains in quantum computing is, these things called qubits, right? They're incredibly sensitive. Think of them like super delicate little quantum dancers. Slightest vibration, temperature change, even electromagnetic interference, boom, they lose their quantum state. That's called decoherence. Keeping them stable, it usually takes weeks of meticulous, often manual calibration for hundreds of qubits as systems naturally drift. It's insane. Weeks? Seriously? That's just wild. So, like a team of engineers just manually fiddling with settings for weeks on end? That doesn't sound very scalable at all. How does Constellation make that process less agonizing? This sounds like the real core problem, right? It's completely unsustainable. But quantum elements, they're using machine learning to basically recognize patterns in qubit behavior. The AI observes how the qubits respond, learns their requirements, and then automatically optimizes their settings. It's like having a self-tuning conductor for your quantum orchestra. What used to take weeks, they're saying, now takes hours. They even showed success in a 2024 challenge with Rigetti, achieving really high fidelities. It's totally mind-blowing.
Hours instead of weeks. That's like a monumental leap in efficiency. But is it just about calibrating those delicate qubits, or does Constellation do, more? Because I can imagine that just getting them stable is only like step one, right?
Oh, it does so much more, Audrey. Beyond just the calibration, the platform handles analysis and programming, so researchers can define their quantum circuits, and then the AI figures out the absolute optimal way to run them on different hardware types, like superconducting systems or trapped ion ones, you know? The coolest part? It can virtually simulate these setups.
Wait, a simulator? Like a digital twin? So they can essentially practice without needing to get on the actual incredibly expensive quantum computer? That's genius.
Exactly, a digital twin. You design, test, and refine your programs in this virtual environment that actually replicates the real processor's quirks, its noise, its limitations. It's crucial because physical quantum machines are so expensive and access is super limited. This lets developers experiment safely and cost effectively without waiting in massive queues or, God forbid, risking live hardware. It's all about pre optimization for better performance on real machines. It really, really speeds things